There are 23 patterns in the Gang of Four book. And when many people are first exposed to the book, there's a tendency to learn about the patterns in isolation. We learn about bridge or proxy and adapter. And while that's a useful way to learn, pick out the pieces as the basic building blocks, in practice, standalone patterns or pattern islands are actually rather rare. Instead, most significant designs actually include many patterns, and those patterns often work together. When these patterns are related and used together, we start to talk about what's known as pattern relationships. And it turns out that there are a number of different types of pattern relationships that are worth mentioning very briefly. One type of pattern relationship is called pattern complements. There are two different variants of pattern complements. In one variant, one pattern provides a missing ingredient that's needed by another pattern. For example, in the Gang of Four book, there's something that's called the factory method pattern that we'll cover later, and it's used to create objects. For some interesting reason, however, the Gang of Four book doesn't talk about how to delete objects or dispose of them. So another pattern was documented later called the disposal method, and that is a complement to the factory method. Factory method creates, disposal method destroys. You can also have pattern complements where one pattern contrasts with another to provide an alternative solution to a related pattern as well. Another pattern relationship you see frequently in the literature are called pattern compounds. And this is where one pattern combined together with another helps to capture recurring sub-communities of patterns that can be treated as a single design decision in response to a particular recurring design problem. For example, the composite command is an example of taking two Gang of Four patterns that can be looked at in isolation and combining them together to make it possible to send a group of related commands in a single operation, which can be useful in certain latency-sensitive type of environments, going across a thread boundary or perhaps a process or machine boundary. A more powerful form of pattern relationship, however, is something called a pattern sequence. And this is where a group of patterns are connected together, where you join a predecessor pattern with a successor pattern or patterns by forming a part of the successor pattern's context. We'll take a look at a lot of these examples when we get into the bulk of the course. And we'll see an example of a pattern sequence where we combine a number of Gang of Four patterns: interpreter, builder, composite, bridge, iterator, strategy, and visitor, in order to be able to solve a much larger group of design problems that arises within a particular environment or domain. The final form of pattern relationship you see documented quite a bit in the literature is something called a pattern language. A pattern language is a network of related patterns that provide a process for the orderly resolution of key development problems within a particular domain. We're not going to talk much at all about pattern languages in this course because it doesn't really lend itself to the kinds of problems that are addressed with the Gang of Four patterns, but there are many other places you can go to find out more about pattern languages. It's worth taking just a moment to compare and contrast patterns, pattern languages, and pattern sequences. A pattern is to a pattern sequence as a photograph is to a traditional film. In other words, a pattern sequence is a linearized presentation of related patterns where there's no branching. You just apply them in a particular order where you're connecting things by having the context of one pattern be fed into by the solution of a preceding pattern. In contrast, a pattern sequence compares to a pattern language the way in which a traditional film compares to so-called hyperlinked cinema, or more conventionally, a hyperlinked document, where you have a network of patterns that can be traversed in various orders, in various ways. You can take one alternative versus another. And that, of course, gives the user of the pattern language much more flexibility in trying to apply it to solve a bigger design space. Needless to say, using pattern languages is very powerful, but there are not that many of them documented because it takes a long time to figure out all the patterns, how they relate to each other, how they're applied in an orderly sequence. So I recommend you take a look at other literature for more information on this important and powerful context.